Good morning, fellow Plexers. This video is for Ben, who has a Windows 11 based server with a 7th gen 7700 i7 processor in it with 16 gigabytes of RAM, and he's just gotten a Plex Pass. So far he's shared a screenshot of a direct play 4K video that's of a lower bit rated nature, so it's been compressed. Somebody's run it through Handbrake. So I wanted to start off with my test server on my Synology DS1019 Plus NAS, which is, I think it's a 7th gen Celeron processor, because that'll have a similar iGPU or similar performance of the iGPU as to what Ben can expect with the iGPU in his 7th gen i7 processor. I really recommend people cross over to an 8th through 10th gen Intel processor at a minimum. An 11th gen is really nice. When you cross the barrier from 10th to 11th gen, you really get excellent performance for hardware accelerated streams. An 11th gen i5 is all you need. You don't need a 13th gen i9. It's just overkill. Plex doesn't require much of the CPU unless you're trying to transcode off the CPU, which is very resource intensive no matter which CPU you have. It's all easy off the iGPU. So with that said, Ben, pull up the web app, click the settings icon. Over on the left, choose transcoder, and you can leave transcoder quality to automatic. I bumped this up a little bit. I think the default is 90. I have this bumped up to 180. You can leave this preset to very fast. With a Windows server, you'll want to disable HDR tone mapping. Plex is still working on that ability for 4K media. If your Plex server isn't capable of handling this, and even though you have hardware acceleration enabled in these two spots, and your transcoder actually shows up here, you can leave it at auto, but might as well change it to what it is, and you can leave this as unlimited and save changes. If you're trying to hardware accelerate a transcode off 4K media with HDR tone mapping enabled, most likely it'll fail on Windows and bump you down to a software transcode, and you won't see the HW symbol in the dashboard screenshot. So disable that for a Windows server until Windows gets it enabled for everybody. Or switch to Linux, mister, right? How hard can that be? All right, so we're going to experiment with some public domain media and media on my NVIDIA Shield. So I keep a couple test servers with all public domain media, but it's tough to find 4K streams. This is actually a 1080p stream. This is a 4K rip, something I did myself, but the rest is stuff I can show on screen. So I've got two versions of this big buck bunny. This one, you notice I've used an addition tag to label it AVI. That's too modern of a codec to use on an older iGPU to force a transcode. It's not going to transcode. This one will. So that's what I'll start. So I'm not sure whether I left this in a transcoded state the last time or not. But if we go to the dashboard and take a look at it, we'll see it's direct playing. So to force a transcode, you just drop down with your selector ring. On this app, just the down arrow gets me here. And I can go over to where it says HD. Oh, actually, it is transcoded. What am I looking at? Oh, it just didn't pick it up when I first started the stream. So this HW means it's transcoded. Off the hardware. Audio is always off the CPU itself. Hardware acceleration is off either the iGPU or the GPU. So this is what it should look like when you force a transcode. So instead of showing you how to force a transcode, it's the same process to go back to the original quality. I can pause that. So now you'll see the original bit rate, and this isn't locked in stone. It kind of depends on the client device and how many streams you're having. This can vary, and it can vary depending where you are in the video too. It's just an estimation. Let's say the actual bit rate can vary depending where you are in the video, and Plex reports an overall estimation. That's more correct. So let's exit out of that. And because this is a test server, I'm never sure where I've left a piece of media. So a black and white 4K media is going to have a lower bit rate naturally because all the different color bits makes it easier. So this is 21 megabits per second. If I drop down and force it into a 2 megabit per second bit rated transcode, you'll see that reflected in dashboard. So the end result of a transcode is always going to be H.264 because that's the most compatible for every client device. And then it's just going to be an audio transcode as well. So again, to take it out, you just pop up to original quality. Start the video. And it's back to its normal state. So the HW means it's a hardware transcode. You'll only see that on the video portion of the media container file. Okay, so let's bring the HTPC client app back in, and I'll show you a 4K video that's not going to transcode well off your iGPU. So this is a rip I've done myself. I can't show the video on screen because I'll get a copyright strike, but I can have it off screen. So I'm just going to resume it off screen. And pause it, and you see it started right up. It's a direct play. It's 104 megabit per second reported bit rate, but you see it's a Dolby Vision, an HDR10. So let me force this into a transcode. 4 megabits per second, 720p. Took a while to start up, but there it is. It's transcoding fine off this older iGPU. I wanted to let it run for a second to see if it started buffering, and it may buffer occasionally, depending on the client device and the connection, which is the root of everything with Plex. You want good local networking infrastructure with a good client device to avoid transcoding. Transcoding is a fail-safe feature. You don't want to force a transcode like I'm doing now because that degrades the quality of the video. I mean, even in this Premiere client app, you can see that's grainy. So let me take it out of transcode. Oh, sorry. Video is paused. You can just see there's more detail with this older film now that it's not being transcoded. So nobody wants to force something into a transcode. So Ben, that's about it. It really is simple to enable your transcoder, your iGPU, settings, transcoder, automatic. Oh, and I don't have a temporary directory set for this. It probably should be temp. Let's see if I have that set for my newer Synology NAS. No, I don't have that set either. Always save changes. But I do have it set for my normal server, which runs on an 11th gen Intel i5 NUC running unraid as only a Docker host operating system. It's got a pair of dissimilar 500 gigabyte SSDs in it, a Western Digital Red NVMe 500 gigabyte drive, and a Western Digital Red SATA SSD. My NUC only has 2 different hard drive options, and Unraid allows me to create a RAID 1 BTRFS cache pool to run Docker containers on. I have no hard drives in that NUC besides those 2, so there's no array drives. And it's a great little OS to point back to the Synology NAS to gain redundancy for the containers, the Docker containers, and it's just a nice little setup. You would not use Windows or Ubuntu or any Linux on that NUC because you can't create a hardware RAID on the 2 dissimilar drive technologies. But with Unraid using a cache pool, you can easily do that. So, a little background on this, and I use half of my 32 gigabytes of RAM for hardware accelerated transcoding. So 16 gigabytes is devoted to hardware accelerated transcoding on that device, and what that does is that significantly decreases the read and writes to those 2 SSDs, which will prolong them. Nothing like that is necessary to do on either of these Synology NAS test servers because they're just rusty hard drives in a RAID array, and they're RAID drives, they'll last forever, hopefully, and having the transcoder written to the array just is more usage for the NAS, and I don't have to worry about anything. Just as you really don't have to worry, Ben, with your setup with just a Windows server. You don't need anything fancy with a transcoder. So, thanks for watching, and anyone else following along, happy plexing.